Okay, today we're going over limiting and excess reactant notes. If I asked you to make a sandwich, we know that a sandwich needs 2 pieces of bread, maybe 3 pieces of ham, let's say 2 pieces of lettuce, 2 pieces of tomato, let's add 1 pickle, and maybe 2 slices of cheese. That'll be a good sandwich. Alright, well let's say we got friends coming over and we look in the cupboard and I see I have 12 pieces of bread, I have 12 pieces of ham, I have 22 pieces of lettuce, I have 20 pieces of tomatoes because I can cut those suckers real small, I've got 8 pickles, and I've got 16 cheeses. Okay? So how many sandwiches can I make out of all that? Well, if I do the bread, this is going to give me 6. 2 to go into 12 6 times. I can make 6 there. 3 will go into 12 4 times here. 11, 10, 8, and 8. So my ham is going to limit the number of sandwiches that I can make. So that's what we're going to go over. So like if I have 2 reactants reacting, one of them is going to get used up first. So the background, in many reactions, one reactant is completely used and some of the other reactant is left over. Our limiting reactant. This is the reactant that gets used up first. This is, oops, I should write the reactant. This is the reactant that gets used up first. All right? It limits, oops, I keep messing up, sorry. It limits how much product is made. Okay? So it limits how much product is made. It gets used up first. So what we need to take home from that is it determines, a limiting reactant determines the amount of a product. Okay? My excess reactant is the one that's left over. So this is the reactant that is left over. Okay? So how to recognize a limiting reactant stoichiometry problem? We're going to have 2 reactants, or we're going to have the amount of both reactants given. So you will be given the amount, oops, the amount of both reactants. Okay, stoichiometry will be only given, we'll have 1 given and 1 unknown, whereas here we'll have 2 givens. That's why it was so important for us to learn how to label. So the steps to solving a limited reactant problem. Got to memorize these guys. Got to know them. All right. We're gonna balance the chemical equation. We're gonna balance and label. Whoops. Label the equation just like we did in stoichiometry. We're going to solve for the product using both reactants. Okay? The smaller amount of product formed is the correct answer. Actually, I don't like the way that's written. It should say the smaller amount of product from the reactant from reactant is the correct amount. Okay, got to know that. So we're going to balance and label the equation. We're going to solve for the product using both reactants. We're going to, the smaller amount of the product from the reactant is the correct answer. Okay, so let's look at one. Yes, you must balance the equation. Ladies and gentlemen, balancing equations is not going away until February 23rd when we hit gas laws, but when we go back after gas laws, we'll go back to balancing. Remember, chemistry builds on itself. So how many liters of ammonia will be formed if 57.3 grams of nitrogen gas reacts with 8.25 times 10 to the 23rd molecules of hydrogen gas? So remember, this is a synthesis reaction because you will be asked to note it. Okay, so let's balance it. We have, we're going to have to put a 2 here, a 3 here. Okay, all right, so we're going to do 2 stoichiometry problems. Let's label first. So question mark liters is 57.3 grams reacts with 8.25 times 10 to the 23rd representative particles. Okay, so make sure you are labeling. So let's get started. We'll just pick nitrogen and we'll use nitrogen as the first reactant. So we start by writing our given 57.3 grams of nitrogen, and we're going to solve for liters. Okay, so the first step is get to moles. Okay, we use the mole map. All right, the words on the top are the words on the bottom. So grams of N2, 14.01 times 2 is 28.02 grams is 1 mole of nitrogen gas. All right, so this was our get to mole step, excuse me. Okay, our second step is going to be our mole ratio. The mole ratio is always the unknown over the given, and we always use the coefficients to the balanced chemical equation. So the words on the top are the words on the bottom, so mole of nitrogen gas, and we see that we have 1 mole of nitrogen gas for every 2 moles of ammonia. Okay. Our third step is going to be get to the unknown. Okay. And we do that by using the mole map. All right, the words on the top are the words on the bottom. So every 1 mole of ammonia, there are 22.4 liters of ammonia. Okay, so we look and we do the math and we get, multiply straight across, divide by the bottom, and we get 91.6. So this equals 91.6 liters. Okay, so nitrogen gas produced 91.6 liters when it reacted with hydrogen. So let's see how much hydrogen produced. So we start with our given 8.25 times 10 to the 23rd representative particles of ammonia. If I'm going too fast, please pause the video. Step 1 is get to moles. So the words on the top are the words on the bottom. 6.02 times 10 to the 23rd representative particles of ammonia is 1 mole of ammonia. Okay. The second step is my mole ratio. So we have the same mole ratio at the top because it's the same unknown, but we have a different mole ratio here at the bottom, which is 3 moles of hydrogen gas. And this third step is get to my unknown from the mole map. So 1 mole of ammonia is equal to 22.4 liters of ammonia. And we do the math, multiply across, divide by the bottom, and we get 20.5 liters. So it says the smaller amount from the product from which reactant is the correct answer. So what is smaller, 91.6 liters or 20.5? Yes, of course, 20.5. Oh my goodness, I put ammonia up here. This should be hydrogen gas, shouldn't it? I apologize. Good gravy. What was I doing? So yeah, this should be hydrogen gas. I'm so sorry, my brain. This was hydrogen gas. So we see that hydrogen gas produced the least amount of product. So 20.5 liters is the amount of product formed. So we need to put 20.5 liters is the amount of product formed. But that's not what my question asks. My question asks, well, it does ask that right here, but my second question is, what is the limiting reactant? The limiting reactant is hydrogen gas. Okay? So I know I went through that quickly. Pause the video and go over it twice, and then attempt these, and we'll go over them on Tuesday.